Hey guys, so these are the notes for Tuesday, April 21st on comparing quadratic functions. By now, this should be page 7, still under Unit 3B because we're still in quadratics in your notebooks. So we'll go ahead and get started. First, let's just do some English. Comparing means we are looking at two or more things and observing what's alike, what's different qualities of them, right? So comparing, the word comparing insinuates that we're going to have more than one quadratic, okay? So we're going to be looking at how two or more quadratic functions and their features are alike / different. Okay? So comparing quadratic functions is really easy if you know how to use Desmos and if you are good at observing qualities of two different things. So when we think about quadratic functions, there's multiple representations we can have. The first representation, which is the easiest, we'll just put A, is a graph. So if I give you the graph of a quadratic equation, I give you a parabola, right? It should be really easy for you to look at a graph and see different features, okay? You guys are usually really good with graphs. So if they give you a graph, all you have to do is look at the picture for the desired features, okay? So that should be easy. You guys know how to look at the graph of a quadratic and find like the vertex or the x-intercepts or the y-intercepts. You learned that in Math 1. The next representation they could give you is an equation. Now, if we're just looking at an equation, depending on the form, we can't always see every feature. So for example, if I give you an equation in vertex form, you can look at that equation and see the vertex. But if I give it to you in standard form, you can't see the vertex, right? So if they give us an equation, it's easiest if we can turn that equation into a picture so we can physically see the parabola. So the best way to do that is to go to Desmos.com and graph it, okay? So if they give you an equation, you're going to graph the parabola so you can see the picture. By typing the equation into Desmos. Okay? So I'm going to stop right there for those two and we'll go ahead and do an example just so you guys can see what the comparing is going to kind of look like. Okay? So let's work on this example together right here. So I've blurred out a bunch of stuff because you don't need it. I want us to look at which has the largest solution, the graph over here or this quadratic. So I gave you two quadratics. We're looking at the features of each one and comparing them, okay? So for the graph, for the picture, we don't need to do anything because you can physically see it, right? So for my picture, I'm gonna make this the green one. I like to color code mine because it's easier for me. Y'all know I got the ADHD. So if I'm looking at this and I'm looking for the largest solution, well, these are my two solutions right here. That one looks like it's around 1.5. And this one looks like it's around 6.5, right? Because remember, solution means x-intercept. So for the green one, the largest solution is 6.5. Now, for this one right here, we cannot physically see that parabola. So you could try to factor it, okay? That would take us some time though, and this one actually does not factor, which is good. So we can't factor it, but if you go graph this equation, then you should be able to see the largest solution, and then we can compare the two, okay? So I'm going to go to Desmos.com. I'm going to click Start Graphing. And then I'm going to type in that equation that this example gave me. So 2x squared minus 12x plus 1. And notice how I didn't even have to type in y equals, okay? So if I look at this graph, I'm actually going to zoom it out so y'all can see. There we go. If you look at your x-intercepts, it looks like it touches down at 0.085. That's what I love about Desmos, is you can just click it and it'll tell you the option, okay? But the largest x-intercept for this pink one is 5.915. So if I look at my two quadratics that I'm comparing, which one has the largest solution? The at 6.5 or the pink one, which had an x-intercept at 5.915? Duh, it's the green one, right? So which one had the largest solution? Your answer would be the graph. Easy enough, right? So when we talk about comparing quadratics, this is what I mean. I'm going to give you 2, sometimes 3, and you'll have to compare them and answer the question appropriately by looking at the different representations, okay? All right, so graphs and even equations are easy because the graph you can look at, the equation you can go put in Desmos, right? So that brings us to our third and final representation, which is a table. And I'll say table / points, because if they give you data points, you could put those in as well, all right? So if they give you a table or points, there's a few things that you have to do before you can actually physically see the picture, okay? So we're going to use Desmos for this. And honestly, it's easiest if I just give y'all some steps. So we'll do it sequentially by steps, okay? So step 1 is going to be go to Desmos and add a new table. All right? After you add your table, and this will make sense once we do it, we're going to click in a new box and type in the base equation for a quadratic. Now, this is where y'all are honors kids, so I'm going to take this a step farther, okay? When I say base equation for a quadratic, that doesn't tell you what form it has to be in. So for this next part, you could type in standard form, you could type in vertex form, or you could type in factored form. Really doesn't matter, okay? So factored form doesn't usually help us out a whole lot, so I usually type in standard or vertex. Again, it's really up to you, but those are the two that I'm going to put down. So option 1, I'll say A. You could type in Y1, and then we're using a squiggle, and we'll talk about Y in a minute, okay, when we do our example. So Y1 squiggle, A x1 squared plus B x1 plus C. Now the reason there's ones right here, you'll see in a minute, is because in Desmos you can add more than one table. So we're just adding one table at a time. So this is going to be table 1, okay? Your other option, I said you could do vertex form. So Y1 squiggle, A parenthesis x1 minus h squared plus k. That's the other one that I would use. Now, I'm going to be honest, I normally do just use the top one, but I've taught kids in the past who like the bottom one better because it's easier to type in. Totally up to you, okay? I'm giving you a choice there. So once you type in that base equation, step 3 is going to be look at the equation Desmos gives you based on step 2. This is your equation for the parabola that best fits the given data points. Okay. We'll talk about what that means in a minute. I do just want you to copy it down right now. So with our examples, you're going to see why I said this is your equation for the parabola that best fits the given data points, okay? These are your only notes for today, or your only steps for today. I still have 3 more examples just because I want to make sure you guys are good. So once you have this down, we're going to go ahead and do more examples. So on our example sheet, I want to start just basically with how to do a table. So I'm going to do, I'll do this one first, and I'll probably go ahead and do another one too for some of you. Actually, yeah, that's fine. I'll do both of them. So for this one, it says find the quadratic equation for the relationship of the horizontal distance, the x's, and the height of the ball, the y's. So I'm going to use my steps that we all just made together. So step 1, add a new table. Step 2, click a new box, type the equation in, and then it'll give us the equation, okay? So back to Desmos.com. Gotta kind of move this so y'all can see the table. So I'm going to exit out anything I already had. Then if you look at this add sign, this is where we go to add